Alright, so in this set of lessons we're going to start looking at this idea of kinematics, which is a mathematical representation of motion and how we can kind of represent motion mathematically. So first topic we need to talk about is the difference between average and instantaneous velocity. So average velocity is really just what it says, the average of velocity over an object over a given time frame. And the way to calculate average velocity is to take the displacement and divide by the amount of time it took for that displacement to occur. Delta x over delta t. Instantaneous velocity is what is the velocity of the object at a given instant in time. We can maybe think about the motion of objects. Both of these values may be helpful in various contexts. Now, one thing to point out about average velocity versus average speed. Let's say I go out and run around the track in 2 minutes, and the track is 400 meters around once. I want to figure out what is my average speed versus my average velocity. Now, the one thing to point out is that these are not necessarily the same number. Remember that speed, this kind of talks about on average how fast I was going. Velocity also includes information about what direction I was going. So average speed is going to be distance traveled versus time, or over time, where average velocity is going to be displacement over time. We talk about the difference between distance traveled and displacement. Distance traveled is how far did I travel, a whole number. Displacement is how am I away from where I started. So my average speed, 400 meters divided by 120 seconds, is 3.33 meters per second. My average velocity, well, because I end up where I started, if I go around one loop of the track, my displacement is 0, and so my average velocity is also 0. Now you might think, how can this be? Well, the obvious answer is that when we look at average velocity, you have to include the fact that I'm changing directions as I go around the track. And then on average, those directions will cancel each other out. The second, or the third variable which might be useful is what's called acceleration. And acceleration really is a calculation of how does velocity change over a given time frame. So acceleration is defined as the change in velocity over change in time. For the vast majority of problems in this unit, we're going to have problems where acceleration is a constant value. It'll actually become clear when we get to our set of equations in this lesson why having acceleration be a constant value is nice. If acceleration is not constant, this equation can be used to find the average acceleration over a given time frame, and then average acceleration and instantaneous acceleration look very similar to average velocity and instantaneous velocity. So what the main goal of this lesson is to kind of come up with 5 basic what we call kinematic formulas. And these 5 formulas relate the following quantities to one another. Displacement, how far am I away from where I started? A, the acceleration. B, the final velocity of my object. V0, the initial velocity of my object. And T, the time it took me to travel. I refer to this set of formulas as the toolbox of equations, and there's a whole host of problems that can be done using just this set of 5 basic formulas. And one thing to point out about this set of 5 basic formulas is we're going to make the assumption that acceleration is constant. So the first one, we're going to use the definition of acceleration, that acceleration is change in velocity over time. Change in velocity would be final velocity minus initial velocity. So A is equal to final velocity minus initial velocity over t. If I multiply both sides by t, I get AT is equal to final velocity minus initial velocity. And if I get rid of the minus part, I get final velocity is equal to initial velocity plus A times t. So there's something that looks like a linear relationship between time and velocity if acceleration is constant. Now, formulas 2 and 3 both deal with the average velocity of an object. We can find the average velocity of an object if acceleration is constant pretty easily. The average velocity is just the initial velocity and the final velocity and divide it by 2. The average velocity has to be midway between it because there's a linear relationship between velocity and time. So if we defined average velocity as displacements divided by time, I could find displacement by taking average velocity and multiplying by time. So v final plus v initial over t, or over 2 times t gives me the displacement. Here I have an equation which relates final velocity, initial velocity, time, and displacement. There's my average velocity formula. Formula number 4, we're going to use the average velocity formula and the definition of velocity in order to find displacement. So the definition of velocity, displacement divided by time, and the average velocity, v plus v0 over 2. So if I set these two equal to each other, v plus v0 over 2 gives you 2x over t. we can rearrange it a little bit. The next thing I'm going to do is plug in my definition of velocity from Formula 1 back in for v. And so I'm going to get 2v0 plus at over 2 gives me x over t. If I multiply everything out by t, I get this, which I call equation number 4. v0 times t plus 1/2 at squared is x. So the relationship between displacement and time in this case looks like a quadratic relationship. The last one is the most complicated of the 5, and we're going to use the first formula and the third formula to hopefully eliminate time. One thing to point out about all of the previous formulas is that I need to know something about time in order to calculate the other variables. So we're going to use the first formula, and I guess this is actually formula number 4, v0 t plus 1/2 at squared x, and get rid of time. I'm going to solve number 1 for t, which I've done. I subtract v0 and divide by a, so the time is v minus v0 over a, and then I'm going to take and substitute that in t in equation number 4. So v0 times v minus v0 over a equals 1/2 a v0, and we get a mess that looks like this thing here. So we get a gigantic mess when we do that algebra. My next step will be multiply everything by 2a. That cancels out some a's, and I'm left with something that looks like this gigantic mess. Now it happens to work out that some of this mess cancels out. 2v0v, 2v0v, those cancel out. You have 2v0 squared plus a v0 squared, one of those cancels out. And so we're left with v squared minus v0 squared equals 2ax. Or if I get rid of the negative squared, v squared equals v0 squared plus 2ax, my fifth equation. Here's my canceling. And so here are the 5 basic kinematics formulas that you're going to have. I would definitely know these 5 formulas. They're going to come up over and over and over and over again in your physics course. These are 5 formulas that you want to have down somewhere. When you come in for a test, a note card is a good place to put them. In your head is another good place to remember these formulas or remember these relationships. The vast majority, in fact, pretty much all the problems we're going to do in this section deal with these 5 formulas. So that's kind of a quick overview of the introduction to kinematics. What we'll look at in the next lesson is how do we apply some of those formulas? What are some techniques we can use?